Welcome to the presentation on radians and degrees. So y'all are probably already reasonably familiar with the concept of degrees. I think in our angles modules we actually drill you through a bunch of problems. Let's see. You're probably familiar that an angle, let me make sure. No, okay. That a right angle is 90 degrees, or half a right angle, or 45 degrees. And you're also probably familiar with the concept that in a circle, and that's my best attempt at a circle, in a circle, there are 360 degrees. So today I'm going to introduce you to another measure or unit for angles, and this is called a radian. So what is a radian? So I'll start with the definition, and I think this might give you a little intuition for why it's even called a radian. So by definition, a radian. Let me use the circle tool and actually draw a nice circle. Okay. So by definition, I'm still using the radian tool, the circle tool. Okay. So if this is, let's say, this is a radius of length r. A radian is the angle that subtends an arc. And all subtend means is if this is the angle, and this is the arc, this angle subtends this arc, and this arc subtends this angle. So a radian, one radian is the angle that subtends an arc that's the length of the radius. So the length of this is also r. And this angle is 1 radian. I think that's messy. Let me draw a bigger circle. Here you go. And I'm going to do this because I always wonder, why do they do radians? We all know degrees, but actually when you think about it, actually makes a reasonable amount of sense. So let me use the line tool now. I'll do this as neatly as possible. So let's say I have that. And let's say that this radius is of length r, and that this arc right here is also of length r, then this angle, let's call it theta, is equal to 1 radian. And now it makes sense that they call it a radian. It's kind of like a radius. So let me ask you a question. How many radians are there in a circle? Well, if this is r, what is the whole circumference of a circle? It's 2 pi r, right? Now you know that from the basic geometry module. So if the radian is the angle that subtends an arc of r, then the angle that subtends an arc of 2 pi r is 2 pi radians. So this angle is 2 pi radians. If you're still confused, think of it this way. An angle of 2 pi radians, so going all the way around, subtends an arc of 2 pi radiuses, or radii. I don't know how to say the plural of radius. Maybe it's radians. I don't know. Well, let's do. So why am I going through all of this mess and confusing you? Well, I just want to, give you an intuition for why it's called a radian and kind of how it relates to a circle. And then, given that there are 2 pi radians in a circle, we can now figure out a relationship between radians and degrees. Let me delete this. So we said in a circle there are 2 pi radians, right? Let's say 2 pi radians. And how many degrees are there in a circle? If we went around a whole circle, how many degrees? Well, that's equal to 360 degrees. So there, we have an equation that sets up a conversion between radians and degrees. So 1 radian is equal to 360 over 2 pi degrees, right? I just divided both sides by 2 pi, which equals 180 over pi degrees. Similarly, we could have done the other way. We could have divided both sides by 360, and we could have said 1 degree, right? I'm just going to divide both sides by 360, and I'm flipping it. 1 degree is equal to 2 pi over 360 radians, which equals pi over 180 radians. So there we have a conversion. 1 radian equals pi over 1, 1 radian equals 180 over pi degrees, and 1 degree equals pi over 180 radians. And if you ever forget these, I mean, it doesn't hurt to memorize this, but if you ever forget it, I always go back to this. That 2 pi radians is equal to 360 degrees. Or another way, and actually it makes the algebra, or the algebra, I guess you could, a little simpler, is if you just think of a half circle. A half circle, this angle is 180 degrees, right? 180 degrees. That's a degree sign. I could also write degrees out. And that's also equal to pi radians, right? Pi radians. So pi radians equal 180 degrees, and we can get the same math. 1 radian equals 180 over pi degrees, or 1 degree, that's degree, is equal to pi over 180 radians. So let's do a couple problems where you'll get the intuition for this. So if I asked you 45 degrees, and to convert that into radians. Well, we know that 1 degree is pi over 180 radians, right? So 45 degrees is equal to 45 times pi over 180 radians. And let's see. 45 divided by 180, 45 goes into 180 4 times, so this equals pi over 4 radians. 45 degrees is equal to pi over 4 radians. And just keep in mind, these are just two different units or two different ways of measuring angles. And the reason why I do this is actually the mathematical standard for measuring angles, although most of us are more familiar with degrees just from everyday life. Let's do a couple of other examples. And just always remember this. 1 radian equals 180 over pi degrees. 1 degree equals pi over 180 radians. If you ever get confused, just write this out. This is what I do, because I always forget whether it's pi over 80, 180, or 180 over pi. So I just remember pi radians is equal to 180 degrees. Let's do another one. So if I were to say pi over 2 radians equals how many degrees? Well, I already forgot what I had just written, so I just remind myself that pi radians is equal to 180 degrees. So pi radians equal 180 degrees. Oh, my wife just got home, so I'm just going to have to leave the presentation like that, and I will continue it later. I think you might get the point. Actually, let me just finish this problem, and then I'll go to attend to my wife. But we know that pi radians is equal to 180 degrees, right? So 1 radian is equal to 180 over, that's 1 radian, is equal to 180 over pi degrees, right? I just figure out the formula again because I always forget it. So let's go back here. So pi over 2 radians is equal to pi over 2 times 180 over pi degrees, and that equals 90 degrees. 90 degrees. I'll do one more example. So if I were to say, let's say 30 degrees. 30, let me write 30 degrees. Once again, I forgot the formula, so I just remember that pi radians is equal to 180 degrees. So 1 degree is equal to pi over 180 radians, right? So 30 degrees is equal to 30 times pi over 180 radians, which equals, let's see, 30 goes into 180 6 times. That equals pi over 6 radians. Hopefully you have a sense of how to convert between degrees and radians now, and even why it's called a radian, because it's very closely related to a radius. And you'll feel comfortable when someone asks you to, I don't know, deal with radians as opposed to degrees. I'll see you in the next presentation.